All right, hey everybody. So this is going to be a video on how to complete the square. So how to solve a quadratic by completing the square. On the left, I wrote out sort of like the procedure. That's the really nice thing about completing the square is it's the same procedure every single time. The procedure at first, it feels a little bit strange. It feels a little bit arbitrary. It feels a little bit like we're doing black magic, and it might not make a lot of sense, sort of what we're doing. But anyways, the upshot of it is that it is procedural. If you just follow the steps, then you're going to arrive at the correct answer. And by the way, kind of the steps are that essentially we're going to take something and we're going to manufacture a perfect square so that we have some quadratic, and what we want to end up with is some binomial squared equals some number. So that's kind of like what we're going to do here. So let's see, I guess rather than going through the procedure, I'll just kind of step by step through this example, following along with the procedure so we can see how it works. So the very first thing, which is kind of sneaky, but it's really important, is that if a is not equal to 1, you have to divide through by a. So remember, a is always the coefficient that is attached to the squared term. Regardless of what the variable is. Here I'm using x, standard x, but sometimes it'll be written, especially in college algebra, they like to use different variables just to get you comfortable with that. It might be a y, it might be a p, it might be an s or a t or an r or whatever. So in any case though, a is always the coefficient that is attached to the squared term, and if a is not equal to 1, you have to divide through by a. So before we kind of start the rest of this procedure, the idea is this x squared term needs to be alone. The coefficient on it needs to be 1. So here my a term is 3. I'll divide through everything, the whole equation, by 3. So when I divide through by 3, let's see, maybe I can list this out like along with the numbering of the steps. So when I divide through by 3, I get x squared plus 7 over 3x minus 9 divided by 3 is 3. So now my squared term, the coefficient on it is 1, and that's what I want. So now I can start with the rest, and that's like a really important step. It feels maybe small, it feels subtle, but if you don't do that, everything else gets thrown off. Everything else doesn't work. The rest of the procedure won't work. Okay, step 2, this is me personally. You don't necessarily have to move the constant over to the right-hand side. It's okay, like, it is possible to do everything sort of on the left, but I think it makes it easier if you move the constant over to the right-hand side. Now, at some point, if you're solving for x rather than just completing the square, you're going to have to do this anyways. So just moving the constant piece over, adding 3 to both sides. Next, step 3, add b over 2 squared to each side. And I've written this a little bit, maybe a little bit ambiguously, because the b that I'm referring to here is not the original b, it's the new b that you have from step 2. So this is like b from, I don't know if you can even read this, the new b from step 2, not the original b, the new b. So my new b, if I look at step 2, my a is 1, b is 7/3, c now is, I guess it was technically -3, but now it's +3. In any case, the b that we're looking at is this middle one. And b over 2 just means divide it by 2. If you have a fraction, that really just amounts to multiplying the denominator by 2. So my b over 2, and I'll just kind of like put this as a note off to the side, b over 2 is equal to 7/6, right? Because b is equal to 7/3 divided by 2 is 7/6. So I want to add 7/6 to each side. And when I do it, by the way, 7/6 squared. When I do it on this step, here's specifically how I do this. Sorry, I'm like trying to talk while I write, and I keep writing funny things or saying funny things. That's kind of how this day is going for me. So adding b over 2, quantity squared, and if I'm adding it to the left, I have to add it to the right. That's why you've got to add it to both sides. So And on the left, I'm going to leave it in this form. Rather than like squaring this term out, I'm going to leave it as 7/6 squared. But on the right, I am going to square it out. Because on the right, I'm going to want to simplify this. So 7 squared is 49, 6 squared is 36. The square gets applied, it sort of gets distributed to the numerator and the denominator. Okay, then step 4, and this is where it feels a little bit like black magic. This piece right here, everything on the left-hand side will factor to x plus 7 over 6, quantity squared. This is where we are manufacturing the square. This is where we have completed the square. It has a very geometric sort of history. Maybe at some points I will make that video. So let's see here. The left-hand side factors to this right-hand side. I just need to clean it up. Oh boy. 36 times 3 is 90 plus 18, so 108. So this will be 108 plus 49 over 36. 108 plus 49 is what, 148, 157. Hopefully I did my math right. 157 over 36. So now we're on, we just completed step 4. Next is step 5, which I've written this as one step, although there are like a few steps that you have to take. So first of all, you have to use the square root property. So at this point, we're just solving for x. Like in a nutshell, that's all that we're doing from this step forward, is we're just trying to solve for x. So in order to do that, I'm going to take the square root of both sides. But when you're solving something that's like something squared equals something else, you can't just take the square root. You have to remember something called the square root property, which all that really means is you take the square root of both sides, but then on the right-hand side, you slap this plus or minus on there. So, and it's going to become the square root of 157 over 36. Just to kind of avoid this becoming an insanely long video, that's going to become 157 over 6. The square root of 36 is 6. And 157, I don't know, that probably could, maybe it can be simplified. Actually, maybe not. I have a feeling that can't be simplified. All right, and then finally, the very last step is to subtract 7 over 6 from each side. So x is going to equal negative 7 plus or minus root 157 over 6. So if you can't see this, this is just subtracting negative 7 or subtracting 7 over 6 from each side. Then over here on the right, I would have negative 7/6 plus or minus root 157 over 6. They have the common denominator, so you can just kind of combine them. So these are the solutions, at least for that one. I want to do one more example because there is one sort of tricky thing that can happen with certain quadratics when you're completing the square. Let's see here. We'll just come up with some numbers. Let's do 5 maybe this time. 5x squared. Try to keep the numbers somewhat small. Let's see, do I want that to be positive? No, I want this to be negative. That's where the trick comes up. Sorry, I'm just coming up with an example on the fly here. Minus 2x plus, I'm just going to try to keep the numbers small. So just to make sure this doesn't factor cleanly, I don't think it does. 5 times 1 is 5. Two numbers that can multiply to make 5, add to make negative 2. Yeah, there's no integers that can do that. So this doesn't, I mean, technically it does factor. This is telling you what it, like right here, this does factor, but it factors to this, x plus negative 7 plus and x, minus, or however it ends up. Yeah, however it ends up. Okay, right. Let me get back to this example rather than like rambling. Okay, so we're going to complete the square on this. So again, the first step is to divide through by 5. So this has the exact same solutions as, and this is not to say that these two quadratics are the same. They're not the same quadratics. If you were to graph both of these, they are different. They'll come out different. But what they do share in common is they have the same roots. They have the same solutions. Okay. So, and that's all that we're trying to find is the solutions to this. So, all right, we've divided through by 5. Yep. All right. so the next thing is I'm going to move the constant over. So x squared minus 2/5 x equals negative 1/5. And here is where things can get a little bit tricky, right? So at this point, again, just kind of like putting my note over here, my b is equal to, you've got to be kind of careful. It's not 2/5, it's negative. B is negative 2/5, which means then that b over 2 is negative 2/10 or negative 1/5. So b over 2 squared is what I want to add to both sides. But again, I want to be careful with the negative. And here's the reason that I insist on this step right here, on not actually squaring this term out. So I'll write this as x squared minus 2/5 x, and then I'll say plus, in parentheses, b over 2, which is negative 1/5, quantity squared, equals, let's see what's on the right, negative 1/5 plus, and then again on the right, now I'll simplify this negative 1/5 squared. I have to add this to the right hand side, but when I square it, it becomes 1/25 positive. Right, so when you square a negative, it becomes positive, and this is why personally I like to leave it in this form, because it reminds me that there is this negative here. Because if you instead write this as x squared minus 2/5 x plus 1/25, you might write the factoring step incorrectly, because when this left hand side is going to factor down to x minus 1/5 squared. So if you square away this sort of negative, at least for me, if I square away that negative, I might have the tendency to write this factored form as x plus 1/5 squared. And it's not. It's x minus 1/5 squared. And this is equal to, let's see, what happens on the right. So this would be, I need to multiply negative 1/5 by 5. 5 over 5, so it becomes negative 5 plus 1, so negative 4 over 25. This might have complex solutions, I don't know. Yeah, I think it will. Which is fine, doesn't matter. That's the nice thing about completing the square, is that you can still weasel out the complex solutions. Okay, so but that's kind of like the big trick that I wanted to show here, is just be really careful when b is negative. You need to carry that negative all the way through to the factored form. So now let's just go through and solve this thing out. So x minus 1/5 equals plus or minus, let's see, just to make it really clear, so on top it's going to be the square root of negative 4, on the bottom the square root of 25 is 5. So x minus 1/5, and then I'll deal with this root negative 4, which is 2i. So plus or minus 2i over 5. So then adding 1/5 to each side, we get x equals 1 plus or minus 2i over 5. And that's the solution. And yeah, as usual, you can always take these solutions. This is two different solutions. This is 1 plus 2i over 5 and 1 minus 2i over 5. You can take each of those solutions and plug them back into the original problem. These ones, both of them, are going to be kind of nasty, but you can plug it in there and it should, equate 0 equals 0. All right, so that's how you complete the square. If you have any specific questions, let me know. I'll be happy to answer them.